We have seen that equilibrium, energy, and kinetics are all related to one another. So let's take a moment to review the situation. When a reaction reaches equilibrium, we can characterize the position of the equilibrium with the equilibrium constant, big K. What we want to know is if K is greater than 1 or less than 1, to tell us if the reaction ends up mostly products or mostly reactants. In kinetics, we're interested in reaction rates, which are characterized by a rate law and a rate constant, little k. It's important to keep the k's straight, since the only difference is capital and lowercase. We have seen that the relationship between these two is given by this expression. Big K equals little k sub f over little k sub r. There are two energy quantities of interest, delta G0 and E sub A. E sub A is the activation energy, and it has a bearing on rate constants. Because of the negative sign in the expression, a larger activation energy leads to a smaller rate constant. Delta G0 and big K both tell us about the extensiveness of a reaction, but with delta G0, it is the sign, positive or negative, that tells us about the extensiveness. Delta G0 and big K are mathematically related. Delta G0 equals negative RT natural log of K. We know that extensive reactions have mostly products, so big K is greater than 1. Logs of numbers greater than 1 are positive, so delta G0 is negative, which we know to be the case for extensive reactions. Logs of numbers less than 1 are negative, so in that case delta G0 is positive, not extensive. We are not going to use these three relationships to quantify any numbers in this course, but you should run across these again if you take the quantitative half of general chemistry. And if they help you here to visualize the relationships, then it's all good.